Hello, everybody. Because I was listening, Elizabeth, Marie, before. I think that there are a lot of things that are in common. So I'll try to go faster in the sense that all the things about corrosion that she said, we had the same, actually the same cases. I'll show you, but I won't get in deep because she explained it so well. Okay, so we had the we were looking. I have been working with the Eduardo Chillida, who is a Spanish sculptor. He died in 2002. He started working in concrete, and several years ago there was a European project called Innova Concrete, who wanted to uh, deep deeper the knowledge of concrete, um, in the sense that concrete is a material which is created in Europe, and so they wanted to acknowledge that and to preserve all the work that, because the people are seeing concrete a lot of the times as something not finished or not good enough. And so finally they chose 9 examples of sculptures and architecture, and one of them was one of the sculptures of Eduardo Chillida. These are some examples of other examples of Eduardo Chillida in concrete. I was so lucky to work in some of them because my father helped him with the concrete, and the problem of this concrete, as you see later, is that the idea of the concrete is not to have a concrete clean or seen as something really new, but something that has like the surface of an antiquity, like a Roman concrete, like something that has time embedded in it. Okay, so to accomplish that, I'm going to show you how they did these sculptures. They start with a small model. They then upscale that. They make it bigger with this. This is a porous span. When this is done, they did all the timber work around the porous span. So it's not a normal work where you define the volume like a pillar or a wall, but instead you do the volume. Actually, you do the volume, and he carved all this volume, and then the formwork applies to it. Okay, and this is something which was a challenge also because we needed to do plans of this, and all this is doesn't have a plane. Okay, okay. This is how they did this. They once they do the formwork, they took it out and then they put the bars in it. You see, it's a very specific timber with a small pieces just to make it round and smooth. Okay, and one of the most challenges we had to are seen here. One is that in order to achieve this kind of patina, this kind of that the work look older than it is, they apply acid chloride, and that's something that if you have here the other presentations, you understand that is the worst thing that you can do. You can see here the acid is in the surface and is active, and what it's doing is taking out the liquid patting of the cement. So the idea is to take that. You can do that with other methods, for example, with water or sand with pressure. But in this case, they use this because they wanted to keep also uh, the formwork. Okay, in the right, you have an example of concrete, which is not normal concrete because it's so red. It's so red because they added a lot of things that are not normal in other concretes, in a concrete or in a bridge or in an architecture, which is iron or types of cement that we don't use anymore, like aluminum cements or things like that. So that they achieve a much colorful, instead of a gray cement or white cement, a most colorful surface. But this is giving us nowadays a lot of troubles. The problems are the same as in the other presentations you have here. We have the problem of the rollbars that change the volume and they break the surface. So the problems are always the same, but it's not the same if you have aluminum or iron in all the mass of the concrete. So also the problem is that we don't know now in which work they use what type of concrete. So it's something we have to deal with. Okay, going to Gijón. This is a sculpture near the sea. It's in a very prominent position. It's a landmark in looking to the sea, and it's an ancient battery for defense. So you see the sea and you see the horizon, and that's why the name of the sculpture. So people come here to look ahead, and there is nothing in between the horizon and where you are in this cliff. Okay, so this was built in 1986, 1987, and is having a lot of problems because of the Gijón is a city very industrial and has a lot of pollution, and also the sea is been a problem. Okay, so what we did here, one of the main problems when you lead with this kind of work is that you need these sculptures are landmarks and are protected, and you need permission, and you have to let the people understand what you are going to do. So first of all, we have to talk with the city hall and make them understand what we wanted to do. Also, the legacy of the sculpture has a lot to say because the sculpture is losing the surface, but they try to keep their image and the legacy of the artist. Okay, so we have a lot of documentation. We have to dig in also from my father's archive, Chillida Lecus archive, the contractor archive, to see what we find there. And also we had in our team the Innova concrete experts, which in Spain were the University of Cádiz and the Eduardo Torroja Institute. Okay, so the first step was to, after we had all the information of historical, we start the in situ collection. So we have to hire a contractor to take the samples, to do the drillings, and then take that to the Torroja Institute. This is a general scheme of how you do this. Mostly is the same all the way. The first part is the analysis of what you have, all the data. You need to take, in our case, samples and take them to the laboratory. With the samples taken, I'll explain the samples and the in situ testing. We can do a diagnosis. The next step is to do evaluation of the technology and the products to solve the problems we find and we define with the diagnosis, meaning that the market is full of products that they want to save and they will promise a lot of things, but when you are dealing with a landmark, you need to have a proven action during years. So we start doing test evaluation of products to see if during years they were providing what they said they would. After that, we can do the restoration project because we know what works and what doesn't, okay? You will execute the restoration, we haven't done yet, and then we do a monitoring. This is a chart of all the things we did. So for the on-site data, we request permits, we hire a small contractor, and then we did a 3D laser scanner, which is paramount in these cases because the plans are not flat. So you have to do something to actually draw a volume. With that, you can do a damage mapping. We did a structural model just in case it didn't work or had some problems that we didn't see. We did a sclerometric test for all the surface. As I understand, you have the other participant has said the main problem always is how close is the rebar to the surface. So if you have a concrete in which the rebar are deep, you won't have problem even if you have a carbonate chlorides or whatever problem. So the problem is how thin is that protection and how and where are they? Okay, we did a ultrasound study in order to do that. Also, we did a thermography study, and that in our case was paramount because when you have detachment in a surface, it's not the same like you work with the pillars, but when you have a surface and you start having detachments, you may have detachments, but that hasn't broken yet. So how can you see where are these? You can see somehow with the sclerometric, right? Because the sclerometric will tell you if this is hard or something. But for us, the thermographic study was paramount. We did also salt cartography. Okay, and with all this, we took samples, I'll show you, and we do extractions of cores to do laboratory tests, which are, I will go, these are very common tests. With that, we came to a diagnosis, okay? In the case of Innova Concrete, we did something that is not usual, is you see there, for modeling. One of the partners of Nova Concrete was a University of Delft, and they had a program to do models of materials. So they see with this, they can put this information in a model and see, not in a test, in a material test, but they can see in a digital model if how it's going to work. The result of these models didn't work out really well. Okay, so they have to improve that. Okay. Okay. This is a chart of the most things we did. Okay. So we started in the left with drawing and permits, and you see all the newspapers there in the front page because this is a very important sculpture for the town. Everybody we had to do some press conference to explain that we're going to work in there. Okay, so we did these presentations. We had the permits, and then we started the on-site sample and the characterization of the surface. After that, we started doing a first application of products that may be good for the that we weren't sure yet. And with this, after a year, when we had the diagnosis, we had to do another presentation to the press in order to make them understand what we are doing with all these site applications to get to know which product actually was the one we wanted to use. Okay. Okay, now I'm going to go quickly. This is like a model of the sculpture from this day they start, and this is just to show how we have to do all these drawings. So they publish it in the press. How we were going to do the fences, to do the 3D scannings, where we're going to do the drillings, how we were going to do it, where is the bars and the drilling. Here's the drilling. The samples of and the information we acquire from the drilling is very similar than the sample of the previous presentation, so it's no need to. But we were looking of course for chlorides in this with these drillings. Okay, and this is a 3D of the sculpture, and here is the samples we took from that arm. This is a photo before. Look, please, here in this place, there were a lot of detachments. The red lines here where detachments had occurred. And when we went up, almost with your hand, you could detach so the detachments, it was really unstable. Okay, so we took all these samples and you see how it was after that. You see the rebars in there, and the rebars are the reason that the detachments had occurred. With this, we of course do the test of carbonation and also the chlorides. In our case, the problem was the chlorides, not the carbonation. Okay, we see the bars. We had these plans, and we could replace all the bars with. Okay, this is one 3D scanning for us was very important in order to do all the mapping of the surface and to actually see where all the problems were. Without this, it's very difficult. In our case, I understand that if you are working with other type of project, is different. You can see that the basement has a different color. I will talk about that later. Okay, so we have this information. With this information, we could deploy, and you use the framework as a guide to put all the problems. Okay, so you see here a attachment. This is a thermal image. What you are seeing here, where it's white, it means that something is happening there. And so we have a corrosion there, but not a detachment. So for us, this is very important because it's showing us something that we don't see with our eyes. For us, is so there, you see that here you don't see in some cases that there are a problem and it's going to break if we don't stop that. So we found that the thermal image, it can be very interesting for this kind of work. So we have to go with this very special place with the cliff and a lot of issues of social security and health. Okay. Okay, this is, as we speak, the problem of the depth of the coating be, between the surface and the rebar. You see here, most of the coating has 40, 50 millimeters, and only a few have 20 or less. Okay, this is the same, more or less the same chart with so we only have problem with thin coatings in the right of the chart. Okay, this is the same chart but by surface to see if the problem was somewhere, and this is with the orientation. So we check, and this is horizontal versus vertical, and you can see here that we have a problem because most of the problems within distance between the surface and the rebar are in places with horizontal. Uh, but they are very few. They are less than 5%. Okay, so we put with the accelerometer we had all these elements. With blue means we have problems, and red is that there are problems, that the rebar is pretty close, and you can see in most of the vertical surface there is no problem, but we have problems in the horizontal. In the horizontal, we think it's because the rebars went down and didn't keep the distance, something like that. You can see here in red also where the problems are. Not is all the places, but where they were on the formwork, they went down. Okay, so these are where our conclusions, and to go is that there is no carbonation almost, because most of the deep of the reinforcement is okay, but we have 3% of less than 20 millimeters in all the surface. But in the case of the horizontal surface, there is a problem because there are a lot more. And also that we didn't have a problem of carbonation, but of chlorides. Okay, we started doing applications to see if we could. We have two types of problems mainly. Afterwards, three. The first one was detachment. The second one was to keep the water out. And the third one was we have a lot of graffiti problems there. Okay, so we decide that to do how do you say, to do the restoration of the sculpture, we should first of all take the salt out of the surface. There's a method to do that, which is carried out when you work with a stone very easily. And then once they are extracted, we want to do a waterproofing. And waterproofing, the problem of the waterproofing is that they change the surface. And when you are dealing with a landmark, you cannot do this. With this is a chart, but you have seen this problem before in other examples. You have the main pathologies, the damage that they provoke, and the materials we decide to test to solve that problems. Okay. These are examples of how we did these applications. These applications are basically water sealants and mortars. Okay, you see in the image of the left, there is a color variation in the lower part of the sculpture. It's more reddish, and we didn't know why. It looks, you see, there are some graffitis around there. And we had a review of this in order to understand what is happening there. Okay, so these are a mortar application. The idea is to have this in order to be proven that they work. We need years. It's not that because the product, the people who do these mortars, they will assure you that they work, but the problem is that they don't. They don't, or in which case they do, sometimes you don't know. You don't know because you don't know the mortar of your sculpture. You don't know if what you're applying is going to have problems. So we had to do a lot of tests in order to see how they develop in the time. These are other mortars to fill cracks, okay? And also these are tests of water repellents. You see, there are some that make a shield, and that makes it looks like it's wet. Also there is a problem with that. In order to do a water repellent that doesn't is not seen as changing the tone of the color. Okay, these are other examples and how we of cracks and mortars and how we tested that. Okay. We test the photographic with photographic validation with a colorimeter. We did peeling test, which are normal, and water sponge in order to see the water how if it kept the capillarity. Okay. Also, we had this problem with the graffiti because it was in a very exposed, very prominent place. So there is a lot of aggression there. And the problem of that was also, you see in the image of the left, the town hall tries to clean the sculpture. And what they did was to erode the surface. So what you are seeing really is the red material of this concrete. So really, in 200 or 300 years, we will see the sculpture in that color because all the surface, the skin will go away and will be a lot more reddish. In any case, the family of Chillida wanted to see, they wanted to keep it like uniform. So we did a small restoration in the bottom in order to unify the different colors of the skin. Okay, so with that, I'm going to finish. Here you have a photo of the sculpture in the reef with the town at the back. And you see so you can see the place and you want to go. You are welcome. It's full of people always, and nothing more. I hope it was interesting for you. Thank you very much.
Thank you so much, Lorenzo. Yes, indeed, it's quite a challenging project, and I will ask you if you have any additional paper that you have published also to Innova Concrete that unfortunately now we don't have, as we are running quite late, we don't have time to go too in deep, but if you have any additional material you can share with us, we would really
Yes,
appreciate it.
okay, I will share that, but for me, the main conclusions, what are the main conclusions? First, you have to dig in really to understand what are the ideas of the sculpture in our case, to understand, because they didn't want to see the sculpture as something new. They wanted to see the sculpture as something with 100, 200 years. So that's the first challenge. You don't want to, with if you are working with an architect, Tadawando, you want to keep the concrete as new, I think. But in this case, it's the opposite. So there was a debate about how, if to keep or not to keep the detachments, because they are scarce, and when you are thinking in something that is old, to have scars is normal. But finally, they decided not to have the scars, but to keep this area of old. Okay, and the main thing, keep water out in our case, because the problem comes with the water and through the porosity goes in. And the problem is, we tested, I don't know, 20, 30 products. They didn't give us what we wanted, because the best product, the one who stay a lot more times and is stronger, is going to be seen like a surface with, it's like a real, like putting a plastic on it. And if you go the opposite direction, in 2 years, like for example, there are water repellents that you almost don't see because they go with nanotechnology. The problem is when you work with graffiti or you work with sand and wind and this kind of erosion, it goes away pretty quickly. So it's a problem with that. So I don't see other way that do something like this and maintain. So keep applying water repellent, but every 3 years instead of every 15 years. Okay. So I think the data of the analysis is, I listened to the Marie Elizabeth, and is almost the same. Okay, so you can apply both cases. Thank you.